How do you spend $1 billion? It's a question that some people in this room might have to answer someday. Well, if you'll stick with me for 4.5 minutes, I'm going to tell you what I think the right answer is. But first, let me introduce you to someone. Are you sure the slides are going? There you go. This is Marie. Marie's a grad student at a top university. She's interested in doing some research, getting published, maybe getting tenure someday. Specifically, she's looking at the correlation between eating green jelly beans and cancer. Well, it turns out that after hundreds of clinical trials, jelly beans do not, in fact, cause cancer. Unfortunately, Marie can't publish that. See, 86% of all published results are positive results, rejecting the null hypothesis and finding out some new fact about the world. So what does Marie do? Well, she tries again, this time with blue jelly beans. That doesn't work. She tries orange and then red, and eventually, after enough tries, we see a headline. Yellow jelly beans cause cancer. So what happened? Well, it turns out that in order to publish something, you only need to be 95% confident in your results. That means 1 out of 20 experiments show a significant result even when there's no underlying connection in reality. This fact, combined with the systematic bias against negative results, has a nefarious effect. Scientists just keep trying things until something works, because they have to get published. They have to get tenure. This is an enormous problem. In 2012, a study done by Nature magazine found that 47 out of 53 medical research papers on cancer were not reproducible. That's science code for complete bullshit. Now, cancer researchers are dependent on the hundreds of results that have come before. They can't go back and test everything. That's why we have science. It's a reliable body of facts that you can use to base future research on. When that paradigm breaks down, when you can no longer trust past results, you end up doing a lot of research down really unproductive paths, looking at things that only looked attractive because someone at some point had some false idea about reality. Now imagine for a moment if we could advance the state of cancer research by 5 years. We'd reach a cure 5 years earlier. We'd save the lives of all the people who would have died from cancer in those 5 years. But that's not all. See, in those 5 years we would have been looking for a cure. We get to move on to other problems. Start solving other problems, curing other diseases. And that's the fundamental point most people don't understand. When you advance a scientific field, it pays dividends in perpetuity. I'm going to wait for my slides to catch up. How's your day going? Good? Great. All right. Scientific advancement is the single biggest human rights concern in the world today. Science has saved countless lives and will save countless more. It's almost impossible to imagine the scale on which science allows us to do good. In the last 100 years, we've discovered penicillin, we've cured polio, we've eradicated smallpox, we made the internet, and in our spare time, we learned how to fly. All that in what, thanks to science, will soon be the average lifespan of a human being. And we did all that with our crappy system. Imagine if we fixed it. But this is fundamentally an incentive problem. Scientists aren't bad people, and they're certainly not dumb people. They're just stuck in a system that incentivizes bad behavior. So how do you fix it? Turns out it's actually not that hard tactically. It just costs money. Number one, you change the required confidence from 95 to 99%. Keep out more bad experiments. Number two, you start publishing negative results. Not only does this solve the whole test all the things problem, it also means other researchers don't waste time going down paths that you've already explored and just haven't bothered publishing. And third, require third-party replication of all results before publishing. Make researchers be specific enough and results significant enough that they can be replicated in outside labs. Now, none of these solutions is free. All of them cost money. So a better question is who's going to fix it? A journal could do it, but it's a huge risk to their business model, a fact that people in this room can appreciate. Government regulation might actually work, but that would require us to elect people who both understand and prioritize science. Sadly, that is not the world in which we live. A much more likely scenario, one person with enough money who understands the impact this could make. One person who buys a few journals and forces a change. Based on recent private equity activity, $1 billion could buy you several dozen academic journals, or better yet, the 5 most well-known and respected ones. So how do you spend $1 billion? Depends what you want. But if what you want is to make the biggest impact possible, to do the most good for the world, then as usual, science has the answer. Thanks.